In this video, we'll discuss the differences between the main group and the transition metal elements and look at some of their characteristics. If you look at the periodic table in the front cover of your textbook, at the top we can see different groups where we say Group A and Group B. Group A we refer to as main group elements, and Group B we refer to as the transition metals. The main difference between these elements is that Group A mainly focuses on the s and the p orbitals and the electrons contained in those orbitals, and the transition metals utilize the d orbitals. So since the bonding is mainly containing s and p in the main group elements and the d orbitals for the transition metals, we need to look at them a little bit differently. So for Group A, the number of valence electrons is equal to the group number. So if we look at each of these groups, we have Group 1A, which has an ns1 electron configuration, Group 2A, which is ns2, and in each of these cases there's 1 and 2 valence electrons respectively. Group 3A has 3 valence electrons, which would be ns2 and p1. Group 4A is ns2 and p2. Group 5A, ns2 and p3. Group 6A, ns2 and p4. Group 7A, ns2 and p5. And Group 8A is ns2 and p6. And this is where we get our octet for the sum of the s and the p orbitals that are in a particular atom. And the properties of all of these atoms are based on the number of the valence electrons that it has. So how it will bond, we've looked at charges of cations and anions before. They're all dictated by the electron configuration. Okay? And the reason we place elements in a particular group is because they have the same properties if they have the same number of valence electrons. If we look at Group B, which is the transition metals, we see a little bit of different properties, and these elements will behave a little bit differently than the main group. First of all, they're all metals. And when we have transition metals form ions, they become cations when combined with other elements. Another difference with the transition metals in the main group is that they do not normally attain the noble gas configuration. So while main group elements will always form a noble gas configuration, the transition metals, they don't do this as readily. So lastly, when forming cations, they readily lose s electrons and some of the d electrons. So for example, If we have iron, it has an electron configuration of argon, 4s2, 3d6. If we look at iron 2+, its electron configuration is argon, 3d6. Okay? Note that iron 2+ is not 4s2, 3d4, it's 3d6. If we look at iron 3+, it's going to have an electron configuration of argon, 3d5. Okay, so when forming cations, they readily lose the s electrons and some of the d electrons.